So, extra questions on Lenz law. The first question, the conducting circular loop enters the magnetic field as shown. What is the direction of induced current in the loop as it enters the stronger external magnetic field? In this diagram, the question stated that this conducting circular loop is entering this magnetic field. So it is moving towards increasing external magnetic field. So we get the information that the magnetic field, the external magnetic field increases, which also means the magnetic flux phi also increases. According to Lenz's law, if phi increases, the induced magnetic field will be opposite direction with the external magnetic field. So we'll be using right-hand grip rule to determine the direction of the current. So the thumb will represent the direction of magnetic field and our finger will represent the direction of the current. So let's say this is the circular loop. So in the diagram before, in the diagram of the question, the magnetic field, the external magnetic field was dotted. That means it is going outside of the page. So this is the direction of external magnetic field. So according to Lenz's law, the induced magnetic field is opposite the direction of this external magnetic field. So here will be the induced magnetic field, the direction of the induced magnetic field. So when we go here, our finger will go clockwise. So that means the induced current will go clockwise. The direction of the current is clockwise. Therefore, the direction of the induced current is clockwise. To the next question, question number 2. Consider a magnet is pushed to the left away from the solenoid. Do you think the galvanometer will show any deflection? If yes, in which direction the galvanometer pointer deflects? So in the question said that this magnet is pushed to the left away from the solenoid. So do we think the galvanometer will show any deflection? Yes, of course, because there's a movement. This magnet is pulled away, moving away. So as we all know, the magnetic field, the arrow points of the magnetic field is always pointed away from the North Pole and inward to the South Pole. So we'll take this magnetic field line as the external magnetic field. So based on the Faraday's experiment, when moving the magnet away from the loop or the solenoid, it will decreases the number of magnetic field lines. So when magnetic field lines decreases, therefore the magnetic flux phi will also decreases. Based on the Lenz law, when phi, the magnetic flux decreases, the induced magnetic field will have the same direction with the external magnetic field. So since the induced magnetic field have the same direction as the external magnetic field will take red color to represent the direction of the induced magnetic field. So it will also be here. So we're going to use the right hand grip rule again. So this thumb will represent the direction of the magnetic field, the induced magnetic field, and our finger will represent the direction of the induced current. So in the diagram just now, I've drawn that the induced magnetic field is in the same direction as the external magnetic field. So when the magnetic field goes to the right, the direction of the current, induced current, will go downward. So from what I've shown just now, the current direction is going downward. When the magnetic field is going outward like this, the solenoid automatically, this side will be north and this side will be south. So when the current flows from here to here, the direction of the galvanometer will go to the right. When the galvanopointer deflects to the right, it will be positive. This also applies to Lenz's law, because when induced current flows in such a direction as to produce a S-pole to attract back the magnetic N pole. So the attraction will involve positivity. Therefore, the direction of the galvanometer pointer deflects to the right or positive.